Hi everyone. Today we're going to be talking about section 9.3, which talks about parabolas. And the great thing about section 9.3 is you guys have actually seen parabolas in the past. All right, so before we get started, where you have seen a parabola in the past is back in Algebra 2 and even in Algebra 1 when we had the basic function y equals x squared. So what that means is the only parabola you guys have seen so far up until today is you have seen a parabola that can open up as well as a parabola that can open down. All right. Then we talked about hyperbolas last section, and that one had two parabolas. So a single parabola is obviously just one picture, one graph, one parabola. And what we're going to introduce today is not only the up and down versions, but also the ones that can go side to side. And again, just like in the other equations, it is all determined by certain pieces of the functions, all right? But what I want to make note of is when you had Algebra 2 and Trig in Algebra 1, back in the beginning of Trig, we always had the function y equals some sort of quadratic, an x squared, but it was always pertaining to x. So whenever x happened to be squared, we knew our picture was going up or down. Today, we're also going to have the option to go left or right, but it's not going to be when x is squared. It's now going to be when y is squared. So make that realization now, because that will really help us here in the future. So go ahead and read the description of a parabola. It's the set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, which is the focus. Things we have seen already, we have seen the focus. However, we've seen foci. We've seen more than just one. But since we only have one picture, one graph today, then there is only a single focus. And then the new item that we're going to see which pertains to a parabola is a directrix. All right. So if you take a look at this picture right below, we have a few things. Obviously, we have the parabola, which is opening up to the right. The directrix is going to go right behind the parabola every time, and it's going to be a straight line. Whether that's vertical or horizontal is totally dependent on the equation. Followed by the focus, which is always going to be placed inside of the shape, regardless of what shape we're talking about. Going back to the basics, of course, we're going to have the vertex. And then again, we are going to have an axis of symmetry, something we don't talk about very often, but it is coming in play. So altogether, a parabola is going to have quite a few features that we will need to consider. So we're going to go ahead and just start practicing here. If I were to take a look at both of these functions, the only difference between the two is where the x and the y is placed. Noticing in the first equation, the x is placed all by itself. In fact, it is also getting squared. So based off of what I know, whenever I have a single y and x is getting squared, I'm going back to Algebra 2 and Algebra 1. I'm going to be graphing a parabola that either opens up or opens down. And that is totally dependent on the equation itself. So what we're going to do here is we're going to have a vertex for a parabola. That's a must, just like centers were a must for ellipses, hyperbolas, and circles. The vertex is always going to be HK. Right now on this page, we don't actually have an H and K, so we're just going to assume that it's 0, 0. So it's going to have a vertex at the center, at the origin. And then we're going to have a focus as well as a directrix in comparison to that vertex. And the ways in which to find what those are is based off of this section here, the 4P. All right, so we'll make a note. 4P is the distance from the parabola through the focus. Okay, so if I were to kind of give you an idea here, we have our parabola. 4P is representing a point from the parabola through the focus, which is always going to be on the inside of the parabola, and then touching the parabola again. It's that entire length. Okay, and the great thing about the 4P value is once I figure out what the real P is, depending on what that value is. So for example, if 4P was replaced with a full 12, then as soon as I take the 4 out of the picture and I divide it out by 4, the remaining P value would be 3. So whatever the single P value is, that will be our focus and directrix information. So that's going to tell us how far from the vertex the focus as well as the directrix are going to be. So that's actually what I'm going to do first. We need to know that information before we even get to the focus and the directrix. So I would solve for P. I'm going to say, for example, with that 12, I would say 12 equals 4P. And as soon as I solve for that, if P ends up being greater than 0, then my graph will open up. And if it's less than 0, my graph will open down. All right. Now that I know potentially what my P value is, then I can head into my focus as well as my directrix. So what's happening is if I were to go ahead and graph a coordinate 0, 0, that's my vertex, that's where it's starting. I'm going to assume that my picture is going to go up, so we'll assume that P is positive just to keep things kind of nice and simple here. So my parabola will look maybe something like this, just giving a sketch, nothing perfect, nothing precise right now. My vertex is 0, 0. And as soon as I find P, that's going to tell me the inside value from the vertex out inside of the parabola. So let's say our P value was 3, just like in the example I gave you. That tells me that my focus is going to go from the vertex up into the parabola, as well as from the vertex away from the parabola, but this time it's going to give me a straight line. So one represents the focus, while the other is going to represent the directrix. Either way, they're based off of your P value. So what happened here is my focus had the same center points, H, had the same K center point, or vertex point, but then what I did to K is I added my P value. So when it's positive, I'm going to add the P, and then when it's negative, I would subtract. Looking at my directrix, this time because it is a horizontal line, it's going to be in relation to Y, and it's going to equal some constant, and I go back to the vertex, which was K, and this time I use my P by subtracting my P. And that will tell me the exact location, the exact equation of the directrix. And last but not least, the last thing I need for a parabola is the axis of symmetry. So you can't really see it here. I guess I'll use a highlighter. The axis of symmetry is going to be the straight line that completely splits that graph in half. So that's the last bit of information we will need. If it splits the graph in half and it's a vertical line, then it's going to give me an x equation, and it's going straight through the vertex with an h value representing your x. So lots of commonalities. We're using a lot of nice things in here and going from there. So let's go ahead and we're going to mix up the function now. This time, instead of having an x squared, we're going to have a y squared. So whenever y is squared, it's going to change my graph. This time my graph has to go left or right, not both, one or the other. All right, and it all depends on that p-value once again. Everything is the same, it's just a matter of how is your graph getting opened, in which direction, and that is all based off of whether it's an x squared or a y squared, and going from there. So, we know that this time it's going to open left or right. Not both, one or the other, because of the reason it being y squared. So I'll make a note of that. And now that we know it's going left or right, we would go back to that 4p value. And the 4p value is not only going to tell us the distance from the parabola through the focus and another point on the parabola, it's also going to allow me to find the focus as well as the directrix, but more importantly, it will tell me whether it's going left or right. So as soon as I solve for p, if it's greater than 0 in this case, then it's going to go right. And if it's less than 0 in this case, then it would need to go left. So it's all dependent on what that p-value is. So your first thing I would do is find your vertex and then head straight into finding your p-value. We will have a vertex on this one as well. It's just also centered at the origin, so vertex is again 0, 0. For this purpose, we will assume that our p-value is greater than 0, therefore our picture will open to the right. So as soon as I do that, then we will need to find our focus, as well as our directrix. This time, knowing that my picture is going to open to the right, again, just getting a sketch going here, my focus is going to be inside of my picture, just giving an idea of where it might be. It's not perfect. It's going to be inside of the picture, and it started again from the vertex, but this time it affected the h-coordinate or the x-coordinate by a value of p. So I'm going to add whatever that p-value was that I've already found. And then when I get to the directrix, it's going to be the same distance from the vertex as my focus was, but it's going to be a vertical line. And because it's a vertical line, that will now give me an x equals. Again, we're talking about the directrix this time. Vertical lines are always x equals. Horizontal lines are always y equals. And if I were to look at this vertical line, it's going to be x equals. We started at the vertex h, and then we moved backwards by a matter of p units. So we're going to subtract a p. And last but not least, we will need the axis of symmetry. Which is the straight line that completely crosses through my parabola. And in this case, that straight line was horizontal, so it would be y equals, and we would take the y coordinate from the vertex, which in our case was k. All right. Again, this time it was horizontal. Now, one thing we've talked about kind of, sort of, but not fully, is that 4p value. So when I go to make my sketch, based off of the information I know on these two equations, I don't know much, so I was just giving a sketch. But as soon as we start graphing real equations, we have to be able to identify two other coordinates on this parabola in order to make our parabola perfect. We don't know how skinny or how wide our parabolas are going to be. In order to determine that information, that is where I'll find these two coordinates. And the way in which I will do that is it is the length from one coordinate on the parabola straight through the focus, also out to another coordinate on the parabola. So it's a straight line, and the total length of that straight line is 4p, which we just so happen to see in that function originally. So I just have to make sure that the length of that total line in between the parabola matches the length that they gave me. All right, so as we head into this next page, again, the only difference is we are now introducing an h and a k, whereas last time there was no h or k, but we knew it was coming down the road. So again, pay close attention. H and K both labeled with X for H, Y for K. And this is where you will find your vertex. Remember, we always want the opposite. If I were to look at these two equations, just to get an idea, based off of the fact that here on the first equation, my Y is a singleton, there's no squared with it. But then when I look to the X, there's a squared with it. What I know from the past is that my options when X is squared and Y is not, my options are either for my graph to go up or for my graph to go down. So I just want to reiterate these facts for you. Okay? Up or down, we know that already. However, as soon as the rules change and my X is a singleton and then my Y gets the squared, my options change and I either can go left or I can go right. Not both, one or the other. Things to consider and think about as we go through these functions. All right, so I'm going to go ahead and start with question 1. Again, if we were to consider the things coming down the road for our test, what's going to happen is this information is going to be completely gone. We don't know what function we're drawing, what we have to list for that specific function, or any of that sort. So keep that in mind. Make sure you're recognizing what's important, what are the key features of these equations as we go through them. So, question 1. We have a y squared equals 12x. Well, first of all, let's identify which one's squared. We only have one squared function, one squared variable. Therefore, we can only be working with a parabola. So I'm just going to make note of that, even though the directions tell me that, but I don't want to assume anything yet. So I now know officially I am working with a parabola. The fact that only y is getting squared tells me that my options are either left or right. And now we start working. As soon as we know which directions are my possibilities, I'm going to find the vertex first. There is no there is no h or k with any of these, so my vertex will be at 0, 0. As soon as we know something, we're going to put it on our graph. The next bit of information is we're going to need to know that 4p value. It's always 4p, the ratio will always be 4p, and it's going to equal the constant that is already with the single variable. So we're going to set 4p equal to 12. Do a quick solving for p, and that's going to give me a 3. Now that we know that p is positive 3, that's going to tell us which direction of our two options. More importantly, it's positive, so it's greater than 0. Therefore, it is going to open to the right. All right. As soon as I know that information, that doesn't mean I get to go over here and say, woo, it's going to go over to the right. Because what I still don't know is how narrow or wide my graph is going to be. So what I get to do, instead of just plotting my line, my parabola, I'm going to go straight from the center, the vertex, and I'm going to go out 3 units to the right, and you just found your focus. and you're going to pull that exact coordinate. So we're looking at 3, 0 for the focus. Instead of going to the right, then I'm going to go to the left, but in order to keep my parabola separate from something else, when I go to the left, you just now found your directrix. Looking at that vertical line, noting that it is vertical, it's going to be an equation with x. And the x-coordinate along that line is always a consistent -3. So you have all of that information. Before we head into the axis of symmetry, which again is not listed in the directions, but that is something important for a parabola. But before I do that, I need to figure out what this parabola actually looks like. So we go back to that 12. Remember when we said 12 is representing that 4p? Well, that tells me that from the parabola through the focus out to the parabola again, I need to have a total length of 12. And so if I wanted from the focus out to the parabola, I'm going to split it in half, and it's going to go out to the 6's. And again, if you counted the squares from the top to the bottom, that should be the total 12. That's where we got those values from. It should be straight through the focus and have a total length of 12. And now that I have more coordinates, I can figure out that my parabola is going to be going from this point, touching the vertex, back out. So I know just exactly how wide or narrow it's going to be. So that is the vertex. Make sure that length is totally 12. And last but not least, we have the axis of symmetry, which again is the straight line that's going to cut the parabola in half. So it's going to cut it in half horizontally for this one. And if it's horizontal, then that means it's going to be a y function. And as soon as I know it's a y function, I look along that line. I ask myself, what is that y value along that line? And it will always be 0. And there we have it, our official information for this parabola. So let's go ahead and try question 2. Same idea. Before we even get started, we're going to assume we don't know what shape we're going to get given. So I see I have a singleton for my y. I have just one y. But then the x is getting squared. And because I see only one is a perfect square and the other one is not, then I know that I am working with a parabola. That's a huge key feature for us. As soon as I know I'm working with a parabola, I'm going to see where is that squared located, and this time it's located with the x. Remembering what I know from Algebra 2, whenever it's located with the x, my options are up or down. And I just have to figure out and make that determination for myself. I have to figure out what that really is. So as always, we will start with the vertex. We do have a vertex other than the origin for this one, and we're going to take the opposites. So for x, my vertex is going to be a +3, and then a -1. As soon as we know something, let's plot it. Okay. I know my options are either up or down, so now I'm going to head into that p value and figure out what it has to be. And so the constant or the coefficient all by itself on this one was 8. I will always set that equal to 4p, giving me a p-value of +2. And because it was positive, which is greater than 0, that tells me it's going to be going up. As soon as I know that information, I take that p-value. It's telling me I'm going up 2. And that is my focus. I want my parabola to go up, therefore the focus needs to be the one that goes up, whereas the directrix is going to go down 2 and needs to be a horizontal line this time. And now that I have that information on my graph, I'm going to label both pieces. So my focus's coordinate was 3, 1, whereas my directrix was a horizontal line, so this time it was a y equals, and that y value was consistently -3 throughout that entire piece. And before I can graph my parabola, I need to have the total length from the parabola through the focus next to the parabola again. That total length was 8. So if I were to cut that in half, going from my focus, I need to go out 4 to the right and 4 to the left, where now I can connect my dots, giving me my new parabola. Of course, we could also extend those further so that it doesn't look too short. And there is the picture. And finally, we finish off with the axis of symmetry, or AOS if you want to do it shorthand. AOS, axis of symmetry, tells us it is the picture that is, or the straight line that is going to cut the graph in half perfectly. In order to cut it in half perfectly and make it symmetrical, just like the name suggests, it's going to be a vertical line. And because it's a vertical line, that tells me that I have an x equals function this time, and the x value that is consistent throughout that entire line will be 3. And there we go. Graphing, graphing, graphing. Now, these questions we've seen time and time again. We know, again, we're going to assume we don't know what function we're going to be working with or what we are working with. But for a parabola, when it comes to these questions, it's actually very, very nice because there's only one variable that is getting squared. So if I make that note that only one is getting squared, I can make sure that at the end of all of this, I'm going to have a parabola. The thing is, I just need to go and clean things up. So a parabola's function states that the squared term is on one side, while the other term, the single term, is on the other. So what I'm going to do first is I'm going to take that 12x, because that is my single term, and I'm going to subtract it to the other side. That's not a squared in the middle there. That is a equal sign. Okay. Now, what I don't know yet is I don't know my vertex, and it's not even in an order where I can know my vertex. So in order to figure that out, we need to bring in completing the square. That will always help me figure out what that vertex is. And if you remember your formula, it's always b over 2 squared, and in this case, our extra piece, our extra b, is going to be the 2. And when I do that, I get a 1. So by completing the square, that tells me that on the left side, I need to take those y's, and then at the very end, I need to add a 1. But remember, whatever I do to one side, I have to also do to the other. And the great thing about this is there was nothing on the outside of those y squareds to factor in, so I'm good there. I don't have to consider, I didn't really add a 1, I added something else. No, we just added 1, so I will add 1 to the other side. From there, I will go ahead and factor just the y's, giving me a nice, perfect y plus 1 squared. And then on the right side, you will notice that there's a negative 12x plus 24. And again, with a parabola, we need the parentheses. If we can get the parentheses, we need them, meaning there is something still factorable on those x terms. Okay, between negative 12x and 24, I can still take a negative 12 out. Yes, I will take the negative, which will turn it into an x minus 2 on the inside. And now we officially have the parabola's function. And since I have that information, I can now find my vertex, which will be 2, negative 1. plotting it on the graph, taking that constant by itself and setting it equal to 4p, leaving me with a p-value of -3, which is now less than 0. And so if I think for a minute, I have to consider, well, what two options did I have from the get-go to open up to? I either had a y squared, so my only options were left or right. But now that my p is negative, that's going to tell me my graph needs to open left. So I go back to the vertex. I'm going to move 3 to the left. And I'm going to plot a point again because I know my graph is going to have to open left. So I want the focus to be included there. And then I'll go back to the vertex and go 3 to the right, but this will be my directrix. And again, we found this information, so let's label it. We got the focus at the coordinate -1, -1, and the directrix was a vertical line telling me that it's an x equals function, and the x-coordinate along that line was 5. In order to get more points on that parabola, I go back to that -12. Now, since we know it's a negative, we already took care of that portion. We know it's going to the left. And then we consider the 12, which tells me I need to go up 6 from the focus, down 6 from the focus, and then I can connect my dots. And there we have my parabola. The last thing I need is the axis of symmetry, which in this case would be the horizontal line, completely splitting my graph symmetrical across that vertex, giving me a y equals, and that equation or that value is consistently -1. So we never know when that completing the square might pop up, so make sure you remember how to do so. Okay. For the next question, it asks us to write the standard form of the equation of the parabola. Again, assuming we're going into our test, all we're going to have told to us in the directions is to write the standard form. So keep that in mind. You have to use the information given to us to determine what function we are working with. So I'm given a vertex and I'm given a focus. Well, if I'm given just a vertex and just a focus, before I make the assumption that, oh, it has to be a parabola, let's just confirm with a picture. We got 5, -2, followed by 7, -2. Knowing that my vertex has to include, my shape has to include the focus, if I have my vertex here on the left and my focus on the right, then that tells me my graph is going to need to go left as well as right. My graph has to go right. Sorry, I was drawing an arrow there. Okay. Now we can confirm that, yes, we are in fact working with a parabola. The equation of a parabola, knowing that it's opening to the right, tells me that my y needs to be squared. I don't know what my 4p value is yet, but I'll put it in there in the function, followed by x minus something. Okay, remember, x does not get squared for this one because it is opening to the right. So now let's take that vertex point, since we actually happen to know it. It was 5, -2, so that tells me it's going to be x minus 5 and y plus 2. And the only thing we have left to figure out is this 4p value. So I don't need to know the full distance from the vertex, from the parabola through the focus out to the parabola again, because that ratio is already done for me. The only thing I need to know is the p value. And so in order to find the P, I have to go from the vertex out to the focus and count those coordinates. So the length from the vertex out to the focus is a length of 2. More importantly, it was going to the right, so I'm still going to make sure that it's a positive because I want my P to be positive as it was moving to the right. And that just told you your P value. So as soon as I plug in a 2 for P in that formula, that will give me an 8, resulting in a final answer of y plus 2 squared equals 8 parentheses x minus 5. Or, for example, if you didn't like that order, you can flip-flop it around the equal sign. And that will be all right as well. All right, but that 8 definitely needs to be with your single variable. Make sure that is the case. All right, question 2. Off the top of my head, this is something that would probably be close to a question on your test. All right, just because the vocabulary used is a very, very good use of the vocabulary, because the only things I give you are the focus and the directrix. Well, the only shape that we have seen at all, this is our last shape today, the only shape that we see that actually has a directrix is a parabola. So right off the bat, you're going to say, well, that has a directrix, so it's got to be a parabola. Then, as soon as I make that note, I'm going to still make a little graph just to get an idea, because chances are you're probably going to have to use it anyways. I have my focus. My directrix is an x equals -4, so I go -4 on the x-axis, and that tells me it's going to be a vertical line. So if the directrix is left and the focus is right, then that tells me that my parabola needs to include my focus, so it's going to open to the right. The question is, I don't know where. So I take a look at the directrix to the vertex, knowing that those are going to be equidistant from the vertex. I'm going to go ahead and find what's the midpoint, what's the center of those. And if I look from -4 to 2, that's a total of 6 units. So if I split that in half, then my vertex has to be 3 units from each, putting me at -1, 4. All right, let's get our function going. We're going to have a y something equals a 4p something x. Again, remembering which one gets the squared, because we know it's going left and right, then that means the y is going to get the squared. Therefore, the 4p should be attached to the x. I kind of jumped ahead there. We just found the vertex, so we can plug that in. It's going to be x plus 1 and y minus 4. And last but not least, we need to find the p value, which is from the vertex out to the focus or the directrix. And it's a total length of 3. Again, be cautious. We are moving to the right, so it should still be +3. And that is your p value. Therefore, we have the function y minus 4 squared equals 12 times x plus 1. Or, of course, you can flip it around the equal sign, but that is still the answer. All right. Last but not least, we're asking you for the standard form. So if I were to look at this function, they did not give me the standard form. There's no way I can find the vertex or the center even, assuming I don't know it's a parabola. There's no information for me to go off of here. So I gotta make that information work. Before I get started, again, I'm just gonna do a quick check of all the exponents. The highest exponent I see is a 2. But I only see that 2 listed once, and because it's listed only one time and only on one variable, I know I'm working with a parabola. Again, things I'm going to need to make sure I do on my test. Because I know I'm working with a parabola now, I want all my squareds on one side, all my squared variables, anything to do with that variable on one side. And then I want the singleton as well as the constant on the other. So what that means is I need to add a 4y, because that's the single variable, as well as subtract an 8 to both sides. So I got x squared plus 8x equals 4y minus 8. We're trying to figure out the exact center point, or the vertex point rather, so we need to now complete the square, because I need that x to be some sort of factorable equation, some sort of factorable quadratic. So if I complete the square, my 8 is going to represent that b in that formula. So I'm looking at 8 over 2 squared. That gives me 4 squared, which is 16. That 16 is now going to be what I have to add to this equation, and whatever I add to one side, I need to add to the other. Again, there was nothing out front that I needed to consider with that 16, so we know we're in the clear. It was just a plain old simple 16. Now, if that x had like a 2 here, for example, then yes, I would need to clean that 2 up and take that out prior to completing the square, much like we have done in 9.2 and 9.1. So keep that in mind as well. You want the shortcut method to factoring. So if it's not giving you the shortcut method, then find a way to get rid of that outside front variable, that coefficient on that outside x squared or y squared even. So now that we've added a 16 to both sides, this is now factorable. And in fact, it is the shortcut factorable method. That's what we're shooting for, trying to get that shortcut so we don't have to go factor by grouping. So what I say is I'm looking for two numbers that multiply to get me 16 and also add to get me 8. And those same those numbers will both be the same. It will be an x plus 4, and since they're both the same, I get to square it. I'll clean up the right side for now. I'll go step by step. So that's going to give me a 4y plus 8 now that I added that 16. And then on the right side, I still don't know the vertex point, so I'm going to factor the right side real quick with just the 4's, giving me a 4 parentheses y plus 2. There's no need to graph this one. The directions don't ask us to, but let's just consider a few things. Taking a look at this function, seeing that x is the variable getting squared this time, that tells me that my graph is going to open either up or down. It will have a vertex of, and again, this stuff is not asked for, but just to think about for a second, the vertex will be -4, 2. It will open, depending on this p-value, it will open up because it is positive. And then that would tell me my p-value, when I set it equal to 4p equals 4, then my p-value is 1. Therefore, if I were to find my focus and go up and down 1 to find my focus and my directrix, that would be -4, 3, as well as a horizontal line at y equals 1. Oh goodness, I lost my -2, didn't I? Sorry, let's fix that. So my vertex was actually -2 for my y. So then that will change my focus to give me a -1 with a directrix of -3. And last but not least, because it's also a parabola, I need the axis of symmetry, which would be a vertical line going straight through the vertex at -4. Okay. Again, all of this information was not asked for on this specific question. Just things I wanted to practice and reiterate for us. Never hurts. All right. So have a look at the teacher notes. Run through this video again if you need. And that will be our parabola.